Good morning to everyone, afternoon or evening, wherever you are in the world. I'm Paul Briscoe with TAG, and joining me today is Peter Wharton, our Director of Corporate Strategy. Good morning, good afternoon, good evening, Peter. I guess morning for you too.
Great to be here, thanks. Yep.
You'll notice, by the way, in our production here, we're going to talk about latency, and we're not using, obviously, a high-end broadcast system here. We're using a web-based tool, and Peter and I indeed have some latency between us, a couple of seconds. So not only are we going to talk about latency, we're going to be demonstrating it every time we interchange here. We have a chat facility in the tool today. If you have questions that come up, please enter them in the chat, and our chat curators will keep those on standby for the end of the call here. We're going to talk about latency. Latency is a complicated issue, and it never really used to be a big problem, right? Historically, if we go back to the beginning of it all, we scanned a camera tube, we picked up a microphone, we put it through a studio, through live analog signal paths to an analog transmitter on the hill, and then at the speed of light delivered it to home and to your TV set, to your screen, all within hundreds of microseconds. Just very, very small latency, and it was never an issue. Until compression arrived, and that's when latency started to bite us, because it takes time to compress video and audio. And so what that means then is anytime you introduce compression paths into a system, you're going to increase latency. And latency comes up in a number of places throughout the production system and the distribution and viewing system with different manifestations. Latency is extremely critical in production, where live decisions are being made in real time. But it's still experienced as well throughout playout, through distribution, and particularly in OTT now, where the technology of OTT doesn't really allow super low latency to occur. So we're going to explore latency in these different areas, the magnitude of the latency, the causes of the latency, and some things you can do to deal with that latency. Peter, can you just generally talk a bit about some of the examples? we're an example by, in reality here. How does latency impact us typically? How do we live with it today?
Well, just like we're dealing with it right now, but we've been dealing with satellite latency all the way back to analog days. And it was only magnified when we went to digital, where reporters in the field and their news anchors would have to deal with this long latency when asking Q&A. And sometimes it meant you change the workflow. Sometimes it meant that you'd have something you'd throw to the talent, and they would know to start, at the beginning of your toss rather than the end, so they would account for latency or something when they really wanted to make it work. But it was really hard when we were just doing interviews with somebody remotely, because you couldn't expect a politician or somebody you're interviewing to actually anticipate and speak ahead of time. So we've been learning to deal with that. But it gets more problematic when we start moving that latency directly into, certain workflows. And I think, one area is we should look at that latency matters different in different parts of the workflows, right? It's a different latency, and so, we should talk about those different workflows and how latency impacts each one of those.
Right. So interesting, by the way, just talking about that last night, watching the docking of the spacecraft to the ISS. I was watching it on a media player off YouTube on the big screen TV. It's an embedded Roku or whatever media player. And just for fun, I brought it up on the phone as well, also on YouTube. And I was experiencing a 20-second differential delay with the phone being later by 20 seconds. Even though it was the same source, the same URL, in fact, but being played on two different devices, so receiving two totally different kinds of streams. And it was just all over the map. So actually, in distribution, tell me a little, how does it impact distribution? Let's work our way up the food.
Well, so in addition, sorry, we'll get this latency figured out yet. So the way this works is like on the distribution side, if you are the first person getting that stream from a stream source, you will probably have a 30-second latency from the source because of the HLS chunking. But once you get that stream, the next stream is being cached closer to you at an edge server, let's say. So now the next person who goes to get that is going to get off the edge server, which is going to take time to cache it and then say, we're pointing you to that and play it. So now there's that extra latency of each server hop that it gets cached through, because that server also has to build a latency cache for protection. So that's how you get to these, I get 30 seconds latency, you get 60 seconds latency, and the next thing you know, you're in a couple minutes latency on some of these web streaming things. And so that's how we built these pretty long distribution latencies and distribution environment. And that only becomes an issue in the distribution side when we care about latency because people are watching a sporting event upstairs and downstairs in the same house, and somebody starts cheering 2 minutes before somebody else does because they saw the goal, or especially if you're betting on sporting events or things like that where latency really matters. And so there are low latency solutions for streaming now, like CMAF, that really designed to reduce that, or even WebRTC. And also the way they build the CDNs that are optimized for live event streaming that's meant to be very low latency. But all that comes at a price because it means that you need a more robust network, and you generally are also having to manage higher bandwidths to deal with it.
Right. There's also this social phenomenon. I know my daughter and her friends do this where and especially now that they're all, hibernating at home, they co-watch programming together. And there's, half a dozen or 10 houses or households, on chat together watching a show. And they experience different latencies, and it makes them kind of crazy. So, just an extension of your upstairs, downstairs football cheering example. So, it's an interesting thing. And at the same time, over the air from the top of the transmitter on the hill, that stuff is super low latency still. So, you have that, and then you have that going through cable system, which adds delay. Then you have that OTT. So there's a whole range, isn't there?
Mm-hmm. And then you move upstream and you talk latency, not just in that distribution world, but then you have latency in playout, right? And that becomes a problem because if you're a network originating a signal, all the stations expect to get it at the same time because their automation is clock driven, not necessarily SCSI marker driven or something. So they're expecting the signals all get there at a certain time. And if there's different latency, then it becomes a problem. In fact, one of the networks I work with, I know they set their network time 3.5 seconds ahead of real time, and it's time zero is in Kansas City for them, the middle of the U.S.
Right.
So that East Coast and West Coast are going to be a little later than the middle of the U.S. And
right.
So we deal with these latencies, and I think that's one of the key things we'll talk about is how do we actually manage latency across these systems, not have it be a problem.
Right. And in playout, you do see that from time to time especially watching cable or satellite originated content where the actual automation switch and the SCSI driven insertion perhaps are, out by a few frames, and you see, a quick little blast of the wrong commercial. It's very interesting. And then, of course, with OTT, as we push the commercials closer and closer to the viewer, that timing becomes even more critical. But how about live production? Right. Talk a little bit about the criticality of latency in live production, because that's where you really need hand-eye latency timing.
Exactly. So when you look at live production, the challenge there is that you have a TD, a technical director, who's running a video switcher, who's running that switcher based upon what they see coming to them. So obviously they want to be able to switch something and push a button and have it switch immediately, which is why it's been troublesome putting that switcher in the cloud, because you want that zero latency feeling of pushing a button and seeing what's happening on air change. But you also have the director who's telling camera people to move and change shots. And it's one thing if the director is sitting in a truck at the football stadium. It's another thing if that director is sitting remotely and telling the cameras to do this, and there's 2 seconds or 3 seconds of latency between when they hear it, when they make the move, and when he sees the move or she sees the move on screen. It makes it really hard to switch events live. So those kind of latencies are far more problematic in live production, as well as just the general latency of if I have two people in two different areas like you and I right now, and we're trying to have a conversation, and there's 2 or 3 seconds of latency between each one of us, it makes it very hard not to step on each other's toes, just even having a chit chat like this.
Yeah, you saying that, I was just thinking I should have a little sign I hold up that says, "Peter, let me speak now," and I could hold that up while you're talking, and it would cue you to turn it over to me. But no, absolutely, these are the key things about live. And live is difficult because latencies add up very quickly, right? If you talked about the scenario you just talked about, the director is calling the cameras, which are already arriving late to the control room, and he calls it over an IP intercom that may be going over the internet to a guy operating the vision mixer elsewhere who has to push a button, which has to go over the internet to get to the switch, the switch application to make the switch. So it's really complicated. So maybe we could switch axis a little bit. Talk to us a little bit about the different sources of latency. Well, where does latency come from in the systems, from the point of view of the system itself, the devices, and all of that?
Well, in the first place, we always introduce latency, especially in live production, is we frame sync signals that are remotely coming into our facility. So if we're putting a switcher in the truck where the cameras are at the venue, then those cameras are already timed to the switcher and there's no frame sync required. But as soon as I start remoting those signals over a long haul link, I'm going to put a frame sync in. So I'm not about a frame of delay. And the switcher itself has its own delay. But then and in that transport, I'm going to probably compress those signals. So then I have codecs, right, that have substantial latency they add to a signal. And on top of that, I might put transport protocols that protect those signals over top of the links. So if I'm using public internet or IP links for those signals, I'm likely to put something like a Zixi RIST or RIST type thing on there, or SRT, to actually protect the signal during transport. So now, all those things add up, and now I'm typically looking at, again, now we're starting to move away from frames and getting closer to seconds of latency, and multiple seconds. And I've actually, and then there's the actual latency in the processor itself, like in the production switch or the playout system. When I was doing a project for a customer to move their network playout into the cloud, I saw round trip latency from their facility up to the cloud through the playout system of a live feed and bringing it back down somewhere between 10 and 17 seconds, depending on how it was architected, without getting to optimization. But 17 seconds was a massive amount of delay to be adding into a network feed at the origin point in dealing with it.
That's
and incredible. So you really have to optimize. Yeah.
So break that down. Latency. That's funny.
Oh, so it's interesting. So to be clear, we were not working to optimize it. We were working to make sure the playout in the cloud was working okay for us at the time. So that was, we were trying to get the other things working right, like the user interfaces and the workflows and the right file, all the other things. Because latency was something I was going to get to last and really deal with. So we ended up having one company doing transport to the cloud using one type of protocol, and then having to convert it to a different transport protocol in the cloud to get to the playout system. And then between the ingest server and the playout server using another transport protocol and compression, and then the playout, and then doing double hop again on the way back out. So all those just, I kept adding a couple seconds here, a couple seconds there. Next thing you know, you're at 10 seconds or 12 seconds of latency, which, and so it was easy to look at this and say, well, these are the things we could get rid of. And probably get it down to 4 seconds, but never get it down to 1 second. It would be my, the reality. And also, we were using public internet for transport. I could have gone to private network connections, MPLS networks, and not needed all of that protection or much lower bucket sizes, buffers, on those protection systems. So, but so over a private MPLS network, I may have jitter that's 10 milliseconds, and I never really have big hits, so I could have a 20 millisecond buffer on my wrist type encapsulation. Mm-hmm. But on public internet, I was seeing occasional jitter up to 150 milliseconds. So I was actually running initially 500 millisecond buffers. So there was a half a second on each one of those links just for the buffers, just to make sure that I could jitter the feeds and have seconds out of order to get fixed.
You were also running not just different transports, but different compression protocols as well. So you were compressing from one to another throughout the system?
The only, obviously it was compressed going up to the cloud, and then it was being decompressed in the ingest and playout engine, and recompressed to come back out of the cloud. So there were at least two compression cycles there. And I do believe it was also being decompressed and recompressed going between an ingest server and the playout server, because the system was architected to have an ingest catch server first before the playout engine that was doing things like auto failover and some other processing. I can't quite remember whether we were doing decompression in that or not. But that was certainly part of it. But those codec cycles we probably wouldn't get rid of. We probably would not have gone uncompressed going to the cloud for playout.
Yeah,
sure. But those are, but you have to manage this. And it's like in live production, again, it's the same thing. If I look at live production, when we talk to our customers, TDs and operators are used to saying, well, I want, zero latency. And they mean zero. And there's no such thing as zero latency, right? So how much is acceptable? Is it 1 frame or 2 frames? You have to look at all the other pieces you're adding into the puzzle too. And then there's the question of, is it the latency between my visual observation of the engine I'm controlling in my control surface and how I'm seeing that? Or is it the latency between the signals getting to it from the remote site? Because those are 2 different latencies that have different impacts on how we do stuff too.
So then let's talk about how we manage latency a little bit. Well, let's start with live production. So what are the considerations we need to keep in mind to build a control room, to build a production environment that exhibits low production latency? Let's say for live sports.
Well, first it's the transport between those cameras and your switcher. You start there. And you clearly want to use uncompressed, which would be zero latency effectively except for path length. Or it would be lightweight compression like a JPEG XS that has very low latency. Subframe latency codecs would be ideal, so you're not introducing significant latency. You'll still probably need a frame sync if you're doing remote production, so you're going to add a latency there. And then the switcher is going to have a certain amount of latency because it's going to have processing, ME buses, DVEs, and such. And then you're going to go to a monitor wall processor, which is going to add typically a minimum of a frame of latency because it has to line up all the signals coming into it. But if it's really well architected and the signals are in fact in time coming into it, you could be looking at getting it down under 2 frames of latency, which is key. And then there's the monitors themselves, which add latency as well because some monitors, have a frame buffer in the monitor as well. So all those different areas, add up to create the challenge of how do you build an end-to-end system with minimal latency for live production.
Right. And that's, I think, key is that the latencies do add up. And if you don't pay attention at every single step, that frame sync, you said, oh, well, it's just a frame sync and you ignored, it's buried in there waiting to add some latency. The other thing I'll mention, because you mentioned frame syncs and we say, okay, it's a frame of delay, but of course a frame sync is there to deal with 2 different time bases. And what that means then is that at some time during the day, it's going to be at 0 delay. And an instant later, it's going to switch to a frame of delay because the input signal is wandering and it has to either drop or repeat a frame. And if you have a number of frame syncs in series, you can get a very beautiful and weird effect, which is very hard to troubleshoot, which is you do a measurement and you go, oh, my latency is less than a frame. And you're looking a little bit later and it's almost 3. And you measure again and then it's 1.8. And it's because all these frame syncs are doing their job, inserting the right amount of delay to keep the signal synchronous. But it's, of course, moving the content in time. Regarding the multiviewing and the monitor wall, I will mention one thing, and that's the monitor itself. 2 things, actually. One is the converter that gets you from the multiviewing device to the monitor wall. If you're coming off an IP multiviewer output, you need to make sure that device itself doesn't include a frame sync. There's no reason to resynchronize yourself going to a panel. What you want to do is have minimum delay getting from IP into HDMI or DVI. But in the monitor itself, it lurks a big problem, and want to make sure we highlight this. There are many modes in TV sets today to make viewers happy. There are things like noise reduction, artifact reduction, picture enhancement, smooth motion, frame uprating, and things like that. And these all make pictures look really pretty. They can make them look quite unnatural. If you watch a 24 frame per second movie and it's rate upscaled to smooth motion, it's actually creepy. It loses the cinema effect, but that's a human perception thing. But the important latency message here is that in order to do these things like noise reduction, like image enhancement, like smooth motion, the monitor needs to keep some frames on hand to do some processing. And that incurs latency between the input and the actual panel. So when you want to have a low latency monitor for multi-viewing in a control room, you need to turn off all the features. And in fact, use game mode if possible, test it and see, which is typically the lowest latency, flattest behavior out of the panel. And that's in addition to all the other nasty panel things like turn off overscan and things like that. So it can be complicated. So what about in playout? How can we design playout systems to minimize latency?
Well, in general, I mean, you're going to typically with a playout engine have a certain fixed latency through it, anywhere from 4 frames to maybe 12 frames. Different systems, I've seen different latencies. But the real challenge is when I have multiple systems for redundancy and they're running in different locations, is to be able to seamlessly switch between those and keep them all in sync. And if you can imagine, if I am running an on-premise system sitting next to me where I have zero latency coming in, zero latency going out effectively, and my control surface is time zero right with that engine. So when I manually go to commercial, it happens right there. And I also have one running in the cloud, and I've got, maybe 7 or 8 seconds of round trip latency through that one. That becomes very problematic because I want to make sure that feed out of the cloud is actually timed perfectly with the one on premise if I have to fail over to it and when I control it. So I end up having to add latency to my on-premise system on the incoming feeds, and again add latency on the outbound side of my playout system in order to emulate the latencies going to and from the cloud. So when I press take, both of them switch exactly the same point in the video passing through them. And that, measuring all those latencies, getting them down to being exact and minimized and deterministic, and figuring that out. And you end up actually also leaving yourself a little bit of wiggle room because you might find that you actually need to increase latency to overcome networking issues as you start doing this, to just be on the safe side. I think part of that is measuring all these latencies and then figuring out where can I minimize them versus where do I need them, and then how do I also add latency to bring all my different systems in sync down the road. And it's a whole new challenge.
Actually asked one. You answered an incoming question, in fact, and it's counterintuitive that you would actually add latency to a system design for any reason. But of course, the example you gave where you have disaster recovery and it's split between premises and ground, or perhaps between 2 regions in the cloud, and differential latency. And so adding latency to part of the system is, in fact, a way to make that work. Also for playout, of course, what's really important, I'll add, is time synchronization across the entire system. Because if you have commercial insertions going, the old-fashioned way with a downstream server, or using SCUDdy messaging or whatever, the time synchronization has to be right on in order to make those clean cuts and not chop the program or the commercial and you end up doing make goods. So that's a complicated problem for streaming television. So let's talk about OTT because that's the difficult one. Talk about minimizing latency in OTT, but also maybe just talk a little bit about the importance of where we should and shouldn't worry about latency in OTT.
Well, I think in OTT, latency manifests itself a couple different ways. One is different latency between different subscribers looking at the same program through different devices or through different paths. And especially if they're all trying to watch it together. Like you were talking earlier about sports, I'm based in Washington, so our favorite sport is called politics. And so, my friends and I were all remotely watching the conventions and the election night together on the Zoom call. And it was like we all had to agree on watching the same TV channels, so at least we wouldn't have different anchors and different other noises. But even then, it was interesting to see like 20 and 30 second difference between what I was seeing on an over-the-air signal of that network versus someone else watching it through a cable system or through satellite or something else. And so you have those different latencies. And of course, if you are actually engineering something for live events where latency really does matter, then you have to think about what protocols I'm using, how large I set my HLS chunks, or whether I move to something like CMAF. I could even go something like WebRTC. And then also, I've seen systems that are architected where you have an origin servers that feed a CDN that feed other CDNs. So I'm adding, these multi-hop CDNs to do distribution. And that works really well most of the time when I'm just doing channels that have file-based playout, and some for economic reasons. But it may not be the right choice if you're doing a live event and you really want to have low latency. So you have to architect the solution based on the latency that the programming requires.
So just your personal opinion, Is latency in OTT something that needs to be solved, or is it good enough and going to get better?
I personally think it's good enough and it's going to get better. I don't see it as a major obstacle. I'm already used to even tuning my radio station, which is not digital, in my car, and hearing the beep at the top of the hour come in 22 seconds after the hour when the news starts, and realize that, they don't back time that, So,
Right.
Although I understand in your country, they do back time it. So that CBC does indeed start at the top of the hour, even after all the distribution and digitizing and codecs and everything else.
They seem to have that
so it's
worked
interesting.
out. Yeah.
Right.
Go ahead. No, go ahead. We got latency. Over to you.
That time back does drive me a bit crazy. Thank you, Roger. So we, I think I don't feel that the latency in OTT impacts my viewing that much. The latency that impacts you more is the time it takes to start an event from when you click on it. It is that kind of thing for the viewer. I think that the zap time is really the most troublesome part of that. Yeah.
It's interesting. Certainly for older viewers like us, we feel it. I think for younger viewers who grew up with the internet and are used to clicking and waiting, it's probably a problem that goes away in time, right? So just interesting to see the consumption-based change. So just to come back to summarizing what we're talking about here, it sounds like you need to design your system for end-to-end latency according to your business needs. I mean, if you're playing out soap operas and commercials all day, you probably don't care too much. If you're doing live events, it's probably a much different story with, wild inserts at the appropriate time of the game and things like that. So really it comes down to a business decision as to how much importance you place on latency and how you deal with it. And you also need to understand how much it really matters, I think, to your business. Because in some cases, again, it's very important. In other cases, you can live with it. We've lived with the satellite delay interviews forever, and it's actually not a problem that's been really fixed extensively. It was fixed operationally by pre-queuing the remote announcer, but they don't even bother anymore. It's just, a shrug. But more importantly, as we go into the cloud, we're going to deal with more of this stuff. And in order to accommodate it, we're going to have to develop new technical solutions in the cloud. So I think people need to be prepared to embrace new workflows as well as they come along, because these new workflows are designed to optimize the use of things like the cloud that inherently has latency. So these new workflows partially exist not just out of creativity and opportunity, but they also exist out of the need to manage the limits of the technology we're working within. And maybe years from now, when everything is, light speed, we won't have this conversation about latency. But today, it's still a thing. Peter, any other takeaways you'd like to add?
Well, it's been a great chat. I really enjoyed it. Thank you, Paul. And also, shout out to my friend Jim Hurwitz. Thanks for the question. We'll catch up. It's always good to see friends coming in on the chat.
Yeah. Likewise, Peter. Thank you. Always a pleasure to chat with you and do this and explore a topic. I'd like to thank our attendees for joining us. We appreciate that your time is important, and we value the fact that you give us a little bit of that to share some of our thoughts. If you have any questions following this, by all means, drop us a line. I'm Paul at tagvs.com, and Peter, you're Peter at tagvs.com, I think. And drop us a note, and we'd be happy to follow up with you one-on-one. And if you have a general question, we'll be happy to share it with the attendees of the call. Thank you so much for attending, and also to our crew behind the scenes. Our little webinar crew doing the production. It does a fabulous job, and we really appreciate their efforts. So from Toronto, Canada, where are you at, Peter?
In Maryland, outside Washington, D.C.
And our live production crew in Tel Aviv, Israel. Thank you to everyone. Good morning, afternoon, and evening to you all.